Hi, the topic today is differentiation. We are looking at determination of equation of the normal to a curve at a point. The question is, the equation of a curve is given by x squared is equal to 4y. Determine the equation of the normal to the curve at point 69 in the form ax plus by is equal to c. Now the first thing is to express y in this equation, y in terms of x. So we have x squared is equal to 4y, so dividing both sides by 4. That means y is a quarter x squared. Now we can sketch this information. You can have it in a diagram. So we have a curve whose equation is y is equal to a quarter x squared, and then at a point on the curve, let's have the tangent line like that, and let's call the tangent line line 1. Then there's another line normal to the tangent line at that point. We can call it line 2. Now we are required to determine the equation of this line here, the normal line. It's normal to the curve, and if it's normal to the curve, then it's perpendicular to the tangent line to the curve at that very point. So the first step, we will be required to determine the gradient of line 1, that is the tangent line, and then use the gradient of line 1 to determine the gradient of the normal line. Remember, the tangent point we are given as 6, 9. So in order to determine the gradient of the tangent line, we begin by getting the gradient function, that is of the curve, that is dy dx. That means you're going to differentiate this function here, y is equal to a quarter x squared, and that means you're going to have the power 2 multiplying 1 over 4x, and then this power decreases by 1, and that means we are going to have a half x. So that is dy dx. Now this is the gradient function. So we can use the gradient function to determine the gradient of the curve at any point. So a point has been specified for us here, that is point 6, 9. So if we use the gradient function, that should correspond to the gradient of the tangent to the line, or rather the tangent to the curve at that very point. So at point 6, 9, the gradient of this tangent line will be obtained as, so dy dx is equal to the gradient of line 1, and that is obtained by simply substituting the value of x here and the value of x for the point. Remember, the point is 0.69, so x is 6, so we have a half of 6. So that means that m1 is 3. But the equation requires us to get the gradient of, or rather the equation of the normal. The requirements are, we need to have the gradient of the normal line, that is line 2. Already we know a point, so we also need a point. They share a common point, that is the normal line and the tangent. And we'll also have a general point x, y. So the next task here is to determine the gradient of the normal line, that is line 2. So we know that the gradients of two perpendicular lines multiply to give us -1. So m1 times m2 is equal to -1 because they're perpendicular to each other. m1 we already have as 3, so we have 3 times m2 is equal to -1. Therefore m2 dividing both sides by 3 is -1/3. Now we have m2, we have the point 69 and the point xy, the general point. So using this, we can use the equation for gradient. Change in y over change in x is equal to the gradient. So we have y minus 9 all over x minus 6 is equal to m2 -1/3. So cross multiplying will have 3y minus 27, that is 3 by this. And then we also have on the other side negative 1 by this, that is negative x plus 6. We are required to express our equation in this form: ax plus by is equal to c. So we let all the terms in x and y to be on the left hand side, and then the constant terms will be taken to the right hand side. So here x comes this side, so that we have x plus 3y. Negative 27 crosses, so that we add it to 6, and that will be 33. And this is the equation in the form required. And with that, we come to the end of the solution to this problem. Thank you for watching. See you in the next video.